So hello. So this is the assignment number 2 from Coursera AI Product Management Specialization. So from the second course, Managing Machine Learning Projects. So I had performed my assignment. So let us go through it. So the first one is opportunity identification. So here I had selected a problem of my in my field of interest. So basically, it is a problem which is related to air pollution. So in a country like India, where I'm staying, so here the air pollution is a major problem, which I could see everywhere in and around the city, like metro cities or the capital city of a state. So where we have more population and people are having uh, everyone is having a car and you can see lots of traffics everywhere. So in this case, so the air pollution is actually getting increased day by day, and so that mostly people are getting affected by some respiratory issues. So for this I have created a machine learning model to safeguard our health. So this is the problem statement is, so basically I had considered the four-wheeler car here, so as a reference to my model. So people while basically traveling in this four-wheeler, mostly they will be getting affected by the air pollution factors like dust or smoke in air. So basically, if all the and I mean the side glass, door, glass, window, which are open during the travel. So during this time, if you're getting stuck in a populated area, or if you're getting stuck in a traffic jam, so those if you in those areas, if you see, the surrounding area will be mostly you could get contaminated with the help of dust or smoke surrounding the area. So for this, so this is the main problem I had selected. So the next one is, so according to the CRISP DM process, I had framed my project in all the six layers. The first one is business understanding. So this is the first one. So here the problem is, so my target user is basically the passengers inside, where the people are sitting inside a four-wheeler air-conditioned vehicle. So the problem is, yeah, the human respiratory system is getting affected by the air pollution factors like dust or smoke in air. So when any of the car side door glass windows are open during the driving state. So why it matters is when you are getting staying long in an air polluted area while driving, so it might cause severe health issues related to the respiratory organs like lungs. So the current state, what we have as a solution is, for all the window glass, we have a manual operation of pulling up the glass is provided now as a protection. This is what the current state. So the next step in the CRISP DMS, again, under the business understanding, we have a factor called defining the success. So here, my expected impact is, so I need to decrease the exposure to air pollution while traveling in a car. So in terms of outcome and output metrics, the outcome is, again, I need to the reduction of exposure to air pollution while traveling in a passenger car, and my output is mean absolute percentage error of exposure reduction by certain X value. So this is what my metrics, as well as the target is also the same, by certain percentage of reduction in exposure to air pollution. And the constraints is, yeah, this safety mechanism will be basically applicable to the AC vehicle only, and because a non-AC vehicle, basically it will be not having any air conditioning system inside. So if this safety mechanism is getting applied here, so my logic is, whenever if the dust or smoke is getting reaching some certain threshold levels, my model will be automatically will be shifting up my all the glass windows up, so my car will be covered completely and the human sitting inside the car will be protected from these environmental pollution factors. So if it is a non-AC vehicle, what will happen is, we cannot sit beyond 5 minutes in a closed area, in a closed car. So it will create a severe problem. So this model basically applies to a air conditioned vehicle only. Yes, the next one is the factors which I'm mainly dealing here is the dust and smoke. So the dust particle, which is actually which can be measured from the air, and we have also the smoke. The smoke data is nothing but it could be of anything which is coming out of a car, or if there's something which is a burning of any, like what I say, burning of any environmental particles, like even a paper or something, which is have actually creating a smoke. So these things will be measured as a factors. And the data understanding from the CRISP-DM process. So the source data is basically it is coming from the sensors. One is dust sensor and the second is a smoke sensor. And both are basically will be mounted in the exterior location in the car, in the favorable location where we can actually grasp the maximum input. The next one is the data preparation. Yes, again, so here the X variable is our dust and smoke sensor inputs, and the Y variable is nothing but the pollution alert. So this is nothing but my internal variable pollution alert, which will be on or off based on my inputs from the sensor. So these are all the variables from the X side as well as in the Y side. So in the CRISP-DM under the modeling, so here I will be considering the logistic regression modeling for predicting the pollution alert signal. So based on inputs from the both the sensors. And here I'll be using the OR logic gate for predicting the target variable based on the inputs from the dust and smoke sensor in the vehicle. So the next one is in the evaluation. Yes, this is like my logic in the predicting the pollution alert. So when my both the sensors are zero means it's nothing but here what I'm mentioning is the sensor values are, I mean the environmental readings which is actually the sensor is reading, right? It is under the threshold. So those cases I had considered zero. So my pollution alert will be zero always. When any one of the sensors getting one means my environmental pollution factors reaches a certain threshold in categories like dust or smoke. So my pollution alert will be on in either of the sensor or both the sensors are getting one. My pollution alert will be also one. So this is what my logic behind in predicting the pollution alert. So when my pollution alert is on, so my power windows of all side doors will be closed. I mean my car will be completely covered, and the AC also will be turned on. If it is not turned earlier, when the AC is not turned on earlier, it will be turned on when this logic is getting applied in the vehicle. So the next one is the validation plan. Yes, the hypothesis, yeah, the pollution alert signal on condition should be considered. But so here the possible features we need to consider, which are all actually contributing to the air pollution or health issues, which is actually affecting the human being. So we need to create a plan which is actually the possible features which we should consider as a important thing while predicting the output. So while testing the hypothesis, we need to find the which are all the possible features which is actually contributing to the air pollution from the environment, and we need to do the analyzing the learning part. It is nothing but we need to find the maximum or possible valid features which is actually contributing to the prediction. So this is what the validation plan. So we need to go through the series of steps. Finally, we need to define the features which is actually contributing to this air pollution. So this is my validation plan. The next one is my machine learning system design. So here I will be considering the edge system because my sensor data will be collected at the real time and it will be processed in the vehicle ECU system, and the decision will be made at the real time immediately because I need to take the action immediately. The online learning and online prediction is also considered because any real-time changes in environment it needs to be taken care immediately, and the prediction needs to be happen immediately because here the delay, if it is happening, then again it will cause a human health issues. So everything should be at the, I mean the result should be happen immediate. So my edge, online learning and online prediction are considered as a system design. And the last one is risk. So here also there is a possible risk under the category data drift. So like suppose the sensor failures or any damages are happening to the sensors in the real-time environment in the car. So it might cause changes in the input values to the ECU in the vehicle. So and that also can be mitigated by training the model with the failure ranges values like timeout and invalid ranges also. Even if the sensor fails, there would be some input data to the ECU based on the failure of the sensors also. Even if you're training with those particular values also, it became the risk can be also mitigated, and it can be resolved again by replacing it with the new sensors, or we need to troubleshoot the problem once the risk is I mean if there is any damage in the sensor, we can replace it with the new sensor also. Yes, so this is what my assignment. So thank you for listening.